Good morning, friends. I'm Gopi Krishna from Glorious Academy, and today I would like to bring some prelims question before you regarding natural hydrogen. As you are reading Hindu newspaper, back-to-back articles are coming on natural hydrogen. It is being portrayed as the next big thing, and they are also saying India has to do a lot in natural hydrogen so that our zero emission goals by 2070 can be achieved. So let's see some sample questions. Because it's a new topic, I want to touch upon some of the fundamentals. Through questions, we will learn some of the concepts of green hydrogen, where it is found, what are the processes through which green hydrogen is formed, and what are the challenges in it, and what are the terminologies involved in it. Directly, we will see some 7 to 8 questions. So this is the first question. Which of the following is another term commonly used to refer to naturally occurring hydrogen found in the Earth's subsurface? So what is the another terminology for natural hydrogen? Is it blue hydrogen? Is it green hydrogen, white hydrogen, or grey hydrogen? You can pause the video if you like, and the answer is white hydrogen. So let us see what are the other hydrogens. There are different terminologies are being given, maybe just to confuse UPSC aspirants. First we will take green hydrogen. Green hydrogen means when we use any renewable energy, because the word green has come, like if we use solar energy and if we do electrolysis and if hydrogen is formed by separating hydrogen and oxygen from the water using solar energy or any renewable energy, then we call it green hydrogen. You must be knowing about this. I am telling for the benefit of those who don't know. And what is grey hydrogen? Grey hydrogen is basically the reaction of steam with methane. Steam with methane is grey hydrogen, and in grey hydrogen the carbon dioxide is released into the atmosphere. And blue hydrogen also involves the same process, steam with methane, but carbon dioxide is captured. That is the difference. So it is not very polluting. So just to review, the natural hydrogen, we will call natural hydrogen as a white hydrogen, and green hydrogen is through electrolysis, and we use renewable energy. In grey energy, steam and methane are interacted, but carbon dioxide is released, so it's polluting, and blue hydrogen is carbon dioxide is captured. So let's go to second question. Which of the following geological processes is not considered a primary mechanism for the generation of natural hydrogen? So be careful about the word not, and because of the pressure in the prelims, sometimes students don't see this and they make fatal mistakes, and I request you, so be calm in the examination. It's very important. So, and read, if you know the answer, then become very careful, read the question again, because when we don't know the answer, it's we will think and we will try to eliminate the options. There it is easy, but when you know the question, we may jump to the answer and we may make mistakes, and that's when we lose out. So be very careful. So not is used. So which is a process which is not a primary mechanism for the generation of natural hydrogen? The answer is electrolysis of water using solar energy. We have seen in the just the question before that this is green hydrogen. Green hydrogen. So, and the question is about white hydrogen, the natural hydrogen. So all the three other processes are related to the production of natural hydrogen. Let us see what are those processes. So first is serpentinization. So what it means is there are olivine rocks in the earth crust. Olivine rocks means the rocks where iron is more. So when water reacts with the olivine rocks, hydrogen is produced. Like usually this happens in the ocean's crust. Water, because of the cracks in the rocks, water enters and the reaction happens between the olivine rocks and water, and as a result hydrogen is produced and hydrogen is stored there. And third is radiolysis of water. What does this mean? In radiolysis of water, some of the earth rocks, the naturally radioactive minerals are available like uranium and thorium, and when they decay, they lead to the, if water is present, radiolysis of water happens and basically hydrogen and oxygen are separated, hydrogen is produced. And degassing from the earth's mantle. This is another process where hydrogen is formed in the earth mantle, and through degassing it is we produce the natural hydrogen. So the answer is B, because not is there, but all the three other processes related to the production of natural hydrogen. Natural hydrogen deposits are considered most promising in which of the following geological formation? The options are coal seams, sedimentary basins rich in hydrocarbons, ophiolite belts and granite intrusions. The answer is C. Ophiolite belts. So what are ophiolite belts? Ophiolite belts are those ocean crust which came up onto the surface because of continental drift. For example, Himalayan region, which was once was at the bottom of the ocean, because of the continental shift, now it is on the land surface, and this is considered to be one of the promising area where natural hydrogen can be found. So in Himalayan region and Andaman regions are the regions where we are expecting to find lot of natural hydrogen in India. This is the ophiolite belt, is the most promising area where natural hydrogen can be formed. This is a geological term. Let's go to the next question. Consider the following statements regarding natural hydrogen. It is generated through geological process within earth. Second, its production involves capturing hydrogen produced from the fossil fuels. Third, it is considered renewable energy source by some researchers. A, 1 only is correct. B, 2 only is correct. C, 1 and 3 are correct. D, 1, 2 and 3 are correct. So the answer is 1 and 3 are correct. So the option 2 is not correct, because it is its production involves capturing hydrogen produced from the fossil fuels. This is not natural hydrogen. So this is the answer. C is the answer. Let's go to next question. Which of the following is a potential advantage of utilizing natural hydrogen as an energy source compared to fossil fuels? What is the greatest advantage? A, higher energy density by volume. B, zero greenhouse gas emissions at the point of use. And C, well established global transportation infrastructure. And D, lower extraction costs in the current technological landscape. So the answer is B. This is the advantage, zero greenhouse gas emissions at the point of use. So it's a clean energy and we want to exploit this. So let's go to next question. Which of the following elements is often involved in serpentinization process that generates natural hydrogen? We have seen this question before. When olivine rocks react with water, hydrogen is produced. That process is called serpentinization. That reaction is called serpentinization. So what is the element that is often involved? Iron is the element that is often involved, because olivine rocks are rich in iron. What is a major challenge currently hindering widespread commercial exploitation of natural hydrogen resource? What is the challenge? One, A, it's high energy density making it difficult to store, or B, the lack of established technology for efficient detection and extraction, and C, it is rapid depletion from underground reservoirs, D, the significant greenhouse gas emission associated with its extraction. So the answer is B, the lack of established technologies for efficient detection and extraction. Because in another areas like fossil fuels, we have established technologies, we have the experience, because a lot of research has been done. This is a new sector. Recently only we have in Mali, this is the area where there was a naturally occurring hydrogen. So from then on research picked up. So it will take some time. As of now, this is the challenge, because we don't have technologies for efficient detection and extraction. So that's it from my side, friends. I am Gopi Krishna from Glorious IAS Academy. Thank you very much.